All right, today we are going to go ahead and finish simplifying radicals, okay? So what we're going to do first is we're going to kind of review what we did last class, okay? So if we had 2 radical 5 times negative 3 radical 15, remember, we multiply the outside numbers, so 2 times negative 3 is negative 6, and then we multiply the radicands. 5 times 15 is 75. And then we break down 75. We always make sure we simplify. Okay, so if I look at 75 using method 1, using that prime factorization, is 25 times 3. 3 is prime. 25 breaks down to 5 and 5. So then we have negative 6 radical 5 times 3. And then we look for pairs. So we have a pair of 5s. So I'm going to circle a 5, cross a 5. 3 does not have a pair, so it stays. My 5 goes on the outside and multiply, so negative 6 times 5 would be negative 30. And then we leave it as radical 3. Now, when we add radicals, we have to make sure they're like radicals. So our radicands have to be the same. So radical 6 and radical 24. They are not the same. So then we look at, can I break down 6? Yeah, 6 can be broken down to 2 and 3, but do I have any pairs? No. So 6 is actually in the simplest form, but 24, let's look at 24. 24 breaks down to 6 times 4. 6 breaks down to 2 and 3, and 4 breaks down to 2 and 2. So we have 3 on the outside, and then underneath we have 3 2s, 1, 2, 3, and a 3. This is all multiplication. And then we look for a pair. And in this one, we have a pair of 2s. So I'm going to circle a 2, cross a 2, and this 2 and 3 does not have a pair, so it stays. The circle comes out, so 3 times 2 is 6, radical, and what's underneath? 2 times 3, which is 6 again. And then that was a plus sign in the front, and we have 2 radical 6 in the beginning. Now, as I look at these two, they now have the same radicand. So now I can add the coefficients. So 2 plus 6 is 8. And we leave the radical the same. So that would be 8 radical 6. Okay. So that's what we talked about last class. Now, today what we're going to start with is we're going to be multiplying radicals, which we've done obviously in Recall 1. But we're going to look at it using the distributive property and FOIL. Okay. And remember, FOIL was used when we had 2 binomials. All right, so as I'm looking at number 1 here, okay, we're going to just do the same thing. We're going to distribute, okay? We're taking radical 5 times a radical 3, which is just radical 15, minus radical 5 times a radical 75 would be a radical 375. Okay. Now, with this, we would have to simplify to see if we can actually subtract them, okay? Now, when we looked at 15, 15 was found by taking 5 and 3. So do we have any pairs there? No. So 15 is broken down. But 375, we took 5 times 75. And 75 can be broken down to 25 and 3, excuse me. And 25 breaks down to 5 and 5. So 375 is 5 times 5 times 5 times 3. So now we have a pair of 5s. So we're going to circle a 5, cross a 5. The 5 and 3 do not have any pair, so it's going to stay on the outside. 5 comes out, so we have 5 radical 15. And then we have radical 15 in the beginning. So now are they like radicals? Yes. Now remember, when we look at radical 15, there's nothing in front, so its coefficient is technically 1. So now 1 minus 5 is negative 4, and we leave on the radical 15. So that would be my final answer there. Okay. All right, number 2 here. Okay. We have 2 radical 3 times the quantity of 4 radical 2 minus radical 98. Okay, so we're going to do the same thing. We're going to go ahead and distribute. So 2 radical 3 times 4 radical 2. We multiply the outsides. So 2 times 4 is 8. And then our radicals. Radical 3 times radical 2 is radical 6. Minus 2 radical 3 times radical 98. The outside number is 1, so 2 times 1 is just 2. Radical. And then 3 times 98 is 294. Okay. Now, we do not have like radicals, so right now I cannot subtract them, but I can break them down. Remember, 6 is broken down by a 2 and a 3, so there's no pair, so I can't break that down anymore. But 294 can be broken down. Okay, we took 3 times 98, so I'm just going to break it that way to make it a little bit easier. 3 is prime. 98 breaks down to 2 and 49. 2 is prime. And 49 breaks down to 7 and 7, which are both prime. So we have 2 radical, 3 times 2 times 7 times 7. We have a pair of 7s. So I'm going to circle a 7, cross a 7. My 7 is going to go out with the 2. 3 and 2 stay under. So 2 times 7 is 14 radical, and 2 times 3 is 6. That was the minus sign. And then we have 8 radical, 6 on the outside. Now these are like radicals, so we can go ahead and combine them. So 8 minus 14 is negative 6, and we have radical 6. It stays the same, and that would be your final answer. All right, number 3 now, we have a binomial times a binomial. So again, we can use FOIL. We could use the box method. I know some of you like the box method, which is fine. Okay, it doesn't matter. That's 100% up to your choice. I'm going to go ahead and FOIL. All right, and FOIL again are my first terms. So 2 times radical 2. 2 is not underneath the radical, so that stays on the outside. So 2 radical 2. My outside, my O, would be 2 and a negative radical 5. Again, 2 is not a radicand, so it stays on the outside, so minus 2 radical 5. My inside terms are radical 3 and radical 2, which, yes, they're both radicands, so we can multiply them. So we get a positive radical 6. And then my outside, or my last terms, is radical 3 and radical 5, negative radical 5, which is a negative radical 15. Now, as I go through this, we have to see if we have any like terms, okay? Radical 2, can I break down? Nope. Radical 5? No. 6 breaks down to 2 and 3, but we don't have a pair, do we? Nope. 15 breaks down, and 15 breaks down to 5 and 3. Do we have a pair? Nope. So guess what? This here is your final answer because we do not have any like terms after that. Okay. All right, number 4, we have a square. I meant to highlight that, sorry. Okay, we have a square. So what does a square mean again? It means it occurs 2 times. So this 2 radical 5 minus 4 is going to be multiplied again by 2 radical 5 minus 4. So now we're going to multiply our first terms, which is 2 radical 5 and 2 radical 5. So the outside numbers, 2 times 2 is 4. Radical 5 times radical 5 is radical 25. Okay. Now we're going to take that radical 2 radical 5 times this negative 4. So it's going to be a negative. Now 2 and 4 are on the outside, so we multiply them. 2 times 4 is 8, and then we have the radical 5. My inside would be negative 4 and 2 radical 5, which is what we just multiplied, so we get negative 8 radical 5. And then my last terms, negative 4 and a negative 4 is a positive 16. Okay. So now we have to look at, can we combine anything? Okay, so let's start with 25. Can 25 be broken down? Yes. 25 can be broken down to 5 times 5. It is a perfect square, guys. So we're going to circle a 5. We're going to cross a 5. So the circle comes out. So 4 times 5 is 20. I do not have anything underneath my radical, so I have no radical left over. Okay. So now as I'm looking at this, let's look at our like terms now. Okay. We have 20 is alike with 16. So what is 20 plus 16? 36. And then looking at this negative 8 radical 5 and the negative 8 radical 5. Those are like terms. So negative 8 and a negative 8 is a negative 16. And we leave the radical 5 alone. And here would be our simplest form. Okay. Now, next step we're going to go into, so that's all our multiplication. Now we're looking at the simplest form when we talked about division, having radicals in the denominator. So we got to talk about this quotient property, okay? Just like multiplication, okay? When I look at the square root of A over B, all it is the same thing as radical A divided by radical B. So if the whole fraction is underneath the radical, it's just taking a radical on the numerator over the radical in the denominator, okay? So if I'm looking at the square root of 3/4, that is the same thing as the square root of 3 over the square root of 4. And then from here, we cannot have a radical in the denominator. We can't have a radical fraction, okay? That's not simplest form. So we look at, can I break down 3? Nope. But I can take the square root of 4, and what is the square root of 4? 2. So it comes out. So that would be my simplest form. Okay. So let's look at number 1. Okay. Simplify. All right, so we have the square root of 15 over 64. Well, in this case, okay, I can't simplify 15 over 64, but I do notice 64 is a perfect square. So what I'm going to do is I'm going to go ahead and just break this into 2 radicals. So I had the square root of 15 over the square root of 64. Now, 15 could be broken down to 3 times 5, but do I have any pairs? Nope. So I'm going to just leave it as the square root of 15. And then 64, if you know, 64 is a perfect square. And the square root of 64 is 8. So this would be my simplest form. Okay. Now remember, you cannot simplify, okay, if I had a problem such as the square root of 5 over 15, I cannot simplify 5 and 15. I cannot simplify those because 1 is a radicand, 5 is my radicand, and 15 is just a constant. It is not underneath the radical, so you would not be able to simplify that. Okay, if they both were underneath the radical, hence the square root of 5 over the square root of 15, yes, I could simplify that into the square root of 1 over the square root of 3. Okay. Number 2. All right, so 81 over x squared, I can't simplify that. Okay. If I could simplify, I would, just because they're both underneath the radical. Okay. Can't do that, so let's go ahead and break it. The square root of 81 over the square root of x squared. Okay. Square root of 81, there is, and that would be 9. Okay. And then the square root of x squared, this is an even exponent, so you can take the square root of it, again, by just dividing 2 by 2. So 2 divided by 2 is 1. So we get 9 over x. Okay. Now, what if we cannot take the square root of my denominator? So like 64, x squared. What if those aren't perfect squares? What would I have to do to get that radical out of your denominator? Okay, that is known as rationalizing the denominator. Okay, to rationalize the denominator, you're going to multiply the numerator and the denominator by the radical located in your denominator. So we do that, we do that because if I have, let's just say 3 over 4, okay? 4, okay, when it says we multiply the top and the bottom, the numerator and denominator by the denominator, it'd be like multiplying by 4 over 4. Obviously, it would be a radical. And 4 over 4 is just 1. So if I multiply 3/4 by 1, don't I get the exact same answer? Yes. So that's what we're trying to do. We're multiplying by 1, okay? A different form of 1, like radical 2 over radical 2, but we will get rid of the radical in that denominator, okay? So let's go ahead and do an example. So as I look at radical 5 over radical 3n, 3n is not a perfect square, okay? And we can't have a radical in the denominator, okay? So this is where we rationalize. So we are going to multiply the numerator and the denominator by the radical in the denominator, okay? So I'm going to multiply this by radical 3n over radical 3n, okay? Because radical 3n over radical 3n is 1, so we're keeping it the same, all right? So let's multiply fractions, remember, straight across. So radical 5 times radical 3n is radical 15n over. Now, when we multiply the denominators here, look at, they're the exact same. So can't I circle one, cross one out? So 3n is going to come on the outside of that, okay? Now, I have radical 15n over 3n. We are done, okay? I cannot simplify 15 and 3 because 15 is a radicand and 3 is not, okay? All right, number 3, we have radical 5 in the denominator, okay? We cannot leave this as a final answer because we have a radical in the denominator. It's not simplest form. So I'm going to multiply the top and the bottom by the radical in the denominator. And my radical in the denominator is radical 5. So I'm going to multiply radical 5 over radical 5, which is 1. So we're keeping it the exact same. So straight across, 1 times radical 5 is just radical 5. And then down here, radical 5 times radical 5, those are broken down. So aren't they the same? So I'm going to circle a 5 and I'm going to cross a 5. So my circle comes out, which is just 5. So we get radical 5 over 5, and I cannot simplify that, again, because one of those 5s is a radicand, the other is not. Okay. All right, number 2 and 4 here. Okay. Radical 2y squared over 3. Okay. Now, I'm going to go ahead and break that into 2 different radicals. Oops. So I'm going to have radical 2y squared over radical 3. Okay. I do not have a perfect square, so I am not able to just take the square root of it. Okay. Now, let's go ahead and rationalize this first. Okay, so we have radical 3. So I'm going to multiply the top and the bottom by radical 3 because that's 1. We're keeping it the same. Okay. And then radical 2y squared times a radical 3. They're both radicand, so I can multiply them. So I get the square root of 6y squared over, now radical 3 times radical 3, they're the same number. So I can go ahead and circle one, cross one. So my circle is going to come out, so I get 3. So right now I have 6y squared over 3. Now 6, looking at the numerator, I got to see if I can simplify that. 6 breaks down to 2 and 3, so that doesn't. But look at y squared. Isn't that a perfect square? Yes, so I can take the square root of y squared. So in my numerator, that square root of 6y squared would be the square root of y squared is y radical 6 over 3. And that would be my simplest form. So you always have to make sure what's underneath your radical is simplified. Okay. All right, number 4, we have that radical in the denominator, so we need to multiply the numerator and the denominator by my radical in the denominator, which is just 2x. Okay. So 7 times radical 2x is 7 radical 2x over radical 2x times radical 2x. They are the same, so I'm going to circle one, cross one. So my circle is going to come out, which is just 2x. Okay. In the numerator, there's nothing there, so that is my final answer. Okay. All right, I'm going to add one more here for us. Okay. I'm going to look at a problem where we have 2 radical 3 over 5 radical 2. Okay. Now, as I look at this, the 2 and the 5 cannot be simplified. They're both on the outside, so I try. 3 and 2, can't simplify that. But I do have a problem, once again, because I have a radical in my denominator. Okay. So now, when I multiply the top and the bottom, I want to multiply that by just the radical. So radical 2 times radical 2. Okay. I could multiply by the whole thing of 5 radical 2, but then you have to simplify a lot longer, okay, or a lot more. So let's go ahead and do our top. 2 radical 3 times radical 2. Okay, 2 stays on the outside. And then radical 3 times radical 2 is radical 6 over 5 radical 2 times radical 2 is 5 radical 4, right? But we'd have to break 4 down. So look here, we have a 2 and a 2. So again, we're going to circle a 2. We're going to cross a 2. So the 2 comes out with the 5. So 5 times 2 is 10. Okay. Now, look at your outside numbers. We have a 2 and we have a 10. Can I simplify that? Yes. 2 over 10 would simplify to 1 over 5. So now I'm going to have 1 radical 6 or radical 6 over 5. And that would be my final answer. Okay. Now I'm going to stop here and we'll do cube roots a little bit later. Okay. And if you have any questions with that, please let me know.